Welcome to Walkabout the Galaxy, the definitely erratic astronomy podcast. You'll have to check out our Patreon for a full explanation.
Erotic.
I didn't say
That's
erratic.
Erratic.
Where the science is universal, the opinions are personal, and the hosts are reunited. We are Strange Charm, top and down the Astroforks, also known as Josh Caldwell.
Addie Dove.
Jim Cooney.
And Audrey Martin.
Coming to you from the Walkabout Studios at the University of Central Florida with 3 real Astroquarks and 1 virtual Astroquark. Follow us on Instagram and anywhere else we may happen to show up, but mainly Instagram where the facts aren't checked. But they can be liked.
Yes.
So like away and tell your friends to listen to the best podcast. I was going to say the best astronomy podcast.
But
Come on.
it's just the best podcast.
Yeah.
Full stop.
Catch our videos on YouTube. We are at Walkabout the Galaxy. You can email us at wtg@ucf.edu. Our stumper today is another one in the Galactic Vacation series.
Great.
Okay,
I love
had a bunch of
vacation.
those.
We
This
should
one
make
is
posters for our vacations. I love those vacations.
That's a great
would
idea.
be some brochures maybe.
Yeah.
Some specials. This time this is a timeshare.
Okay.
Okay, have you ever been timeshared?
I've
I
never
haven't.
been timeshared.
I've
Jim,
only
have you
seen the
been
South Park
timeshared?
episode.
I've been 2 timeshared, but I've never been sold a timeshare.
Oh, but you've experienced it. Well, guess what? Now
I guess
you have
I've
been
experienced
sold.
one.
Oh, you
Yeah.
have also.
Yeah.
Really?
Yeah.
Extended family.
Is that a thing still?
Yeah.
It is a
Oh,
thing.
100%.
It is absolutely a thing.
I've somehow avoided it my whole life.
That's because you're not going to the fancy
That's
places
because
where
you're-
they're like,
That's
I'm not
because-
fancy?
yeah.
Well,
that's what
it's
I just
because
said.
you're not accepting you can have a 3-night stay in New York City for a special reduced rate. You only just
come
have to
listen
sit
3 hours
for
of
a
presentation.
2-hour timeshare presentation.
Ugh.
Yeah. But now you actually have been sold a timeshare.
So I already sat through the
Congratulations.
presentation.
Yep.
Yep. And the
Got it.
trick
I
to
don't remember.
the trick to this timeshare is you're going to have to spend a week a year there
Okay.
for the next 20 years.
Oh.
And it's not on planet Earth.
Does it get passed to our children or whatever?
If
that
you
happens
want.
with timeshares.
Children
Yeah.
or whatever.
You-
So
you own it.
dog.
You own it.
Great.
You have bought the timeshare, and the stumpery part is you must spend a week there
Okay.
for the next 20 years.
Great.
Love it.
After that, if you can't stand it, you can just forget about it or sell it.
Forget about it.
Where do you go? Habitability, safe environment, that's taken care of. So you don't
Okay.
need to worry about that, but it has to be on a surface of a place where you could build a timeshare building.
Can you build it underground?
If you are like a...
You
I'm
might need to
stumped.
for safety.
Dwarf.
What? No, you don't need to for
No,
safety.
no, okay.
Safety is taken care of.
Okay. Okay.
If you want to build it underground,
you could.
you may.
Yeah.
If you have some sort of strange,
Yeah.
You're a
Views.
mole.
If you were a mole.
If you were a mole.
Yeah.
maybe you want a
There was
view of
interesting-
lava tubes
Yeah, I was
or
going to
something.
say, oh, okay.
Maybe you want to have it be like,
What if you want to build it like on Europa underground and you're like surrounded by ice
or in the ocean.
or in the ocean? Yeah.
but it's so dark.
But you'd
some
have your
spotlights.
lights. You'd have
some
spotlights.
Ooh.
What about like on the cliff wall of the Valles Marineris?
Yeah,
So
something
like
like
it's
that would be super
underground,
cool.
but then you've got a balcony
Oh,
that's like
yeah.
on the shelf.
I love
like
that.
Mesa Verde.
Yeah.
You know what I'm
yeah,
talking
yeah,
about?
Yeah. I can picture it.
Yep.
So
Great travel poster.
I'm thinking that might be mine.
Might say IO.
Not that anybody asked. You're saying IO.
IO.
IO, so good.
If
IO.
there'd be like volcanoes going
Yeah.
all the time, you get this nice view of Jupiter.
Amazing
maybe
view
the
of Jupiter.
other moons if they're aligned.
Mm-hmm. Definitely.
Asteroids occasionally, maybe.
Sure.
Volcanoes and everything.
Yeah.
Yeah.
I would like the moon facing Earth. I want to see Earth and see all the fun clouds and weather that I'm avoiding.
And laugh at all those
While I'm-
suckers that are there while you're on vacation.
Yeah.
It's a kind of,
I
Earth
like
is
it.
pretty.
I think it is.
It's the prettiest planet.
It's
So-
kind of my favorite planet.
Me too.
Yeah.
Yeah.
So you have a nice view of the Earth.
Yeah.
I'll go for that. I'm going for a cliff dwelling on Valles
I like that
Marineris
too. I like
it.
on Mars.
My second option is Europa in the ice.
Europa in the ice or in the ocean?
Like ice just above the ocean. Maybe you can look down into the ocean. Oh my God, what's happening today?
Okay. Interesting. Something terrible happened.
No.
We're having all sorts of technical fun today.
Yeah.
Did the
We lost Jim for like a
Brief second.
5 seconds, but
We're
he's
back now.
and we're recording.
and that's
that
still
totally-
recording.
Yeah.
Great.
And totally, I had an absolutely brilliant joke that I forgot because of that technical glitch.
No!
Technology.
So many things going wrong in such a short amount of time.
Had something to do. Oh, I know what it was.
Oh, tell us.
It's going to be
If you're
so
on
funny.
Io and all those volcanoes, it's going to be like Silo.
Oh, yeah.
You'd have to go out and clean your cameras.
Sure.
You'd have to have some wool
Sure.
to go out and
Wow,
clean
clean your
because you're
cameras.
going to
Maybe
get covered
thermal
up with all
tape.
that stuff.
Mm-hmm.
Yeah.
Spoiler alerts.
Well, today we'll talk about, speaking of Europa.
Oh, wait, we didn't
What,
hear Jim, and also we don't hear Jim.
Oh, I can hear you
Can we?
on the computer.
On the computer.
Jim.
I don't think that's
No,
Jim's thing. I think
That's not Jim's
not-
thing.
It's us thing. Just a second. Do the mic.
Jiminy Criminus. Hello.
Oh, it's like the roadcaster isn't attached.
It's like the roadcaster isn't attached.
This is such a fun recording today.
This is
It's,
Oh, I
yeah,
can
it's
hear
the
you again.
time, so what are we gonna do? You know,
Great,
it's
great.
Our first podcast ever.
Everything is
That's
awesome.
That's still recording too.
That's good. This is good. We can hear Jim.
Everything is fine.
there's going to be an amazing blooper reel for episode
This one is
386.
chock full of bloopers.
Is it possible to fix this to stitch it together?
Yes.
Okay.
It would have been until you said that. Now everybody knows there's a problem. Thanks a lot, Jim. Way to ruin the
That's what we
episode.
say. It's stitched together. Now you're hearing this. All right.
Yeah.
Oh, well.
So where are you going, Jim?
Oh, I'm going. You guys, your imaginations are not good. You
Oh,
stay.
they are. We just don't know enough about places
Ouch.
in other solar systems to
Yeah.
Well.
guarantee time
Yeah,
there.
we're not unimaginative. We're just dumb.
Hey.
Yeah.
No, I'm going the star S2 or possibly S55. These are the two closest known stars to the galactic center.
Those don't sound like
Sagittarius A
like planet names.
Well,
S-
so they don't have
You
any
can't
planets
land
that
on
we're
a star.
aware of.
Are these ones
However-
with these super fast orbits that they've seen like zipping around?
Yeah. These things they're within I don't know 300 or 400, 400 Schwarzschild radii of that black hole. They're moving at something like 1 or 2% the speed of light around
Oh my
those
God.
things.
Okay.
How far is
when
that
they're- at
in
least when
other
they're at,
in astronomical units?
Yeah, I mean it's
Yeah.
30 or something astronomical units. They are so that would be a really badass view of the center of the galaxy, and obviously a very dangerous place to be. But you said I was going to be safe.
So
So.
you're
You're gonna be safe, and
also.
it's only a year.
Yeah, it's 1
Oh,
week
is there time dilation stuff that happens? Oh,
synchronous. Synchronous owing.
we're very synchronous.
Yeah,
today.
we are.
We haven't seen each other in a while, so we're synced up.
You're
Yep.
locked in. Well, and I guess you just sort of assumed, Jim, but I didn't tell you that actually transportation is also taken care of with your timeshare, instantaneous
Woo, thank you.
transportation,
That's an expensive
Good.
trip.
because that would have
Yeah.
been problematic
That's a lot
otherwise
for your life.
choice. Yeah. Today we'll talk about ocean worlds, exploring large-scale structure of the universe, and much more. But first, this episode of Walkabout the Galaxy is brought to you by diffraction. Don't get distracted, get diffracted. If everything is falling on you all at once and you feel like you can't get out from underneath a constant hail of demands for your time, use diffraction to spread those tasks out into a predictable and manageable pattern.
Nice.
Bending waves since the dawn of time and everything from light to water to planetary interiors, diffraction helps you deflect without regret and keep your focus on the most important things in life. Mention Walkabout the Galaxy for a special offer on two-slit diffraction
Ooh.
and enjoy canceling or enhancing the waves coming your way.
I would like to do that.
Diffraction, delighting you always.
Delighting you always. First of all, Diffraction needs a time management podcast to help me with my life. But also, maybe I'll just buy the product. Thank you,
Yes,
Diffraction.
yeah. There's a special. Act now.
Act now.
Delighting you always.
Delighting
Yes.
you always.
Surfboards.
Why not?
Cadbury egg.
My first thought was donuts.
Jim says Cadbury eggs.
Cadbury eggs.
We're all thinking food.
Yeah, but I
Yeah.
thought there's no way it's food. So waves, surfing,
Yeah.
surfboards.
The delighting you is, but it's you'll
Is
never.
it like
it's
Phillips? No, we already
it's
had
kind of like
Phillips.
Phil's Canon.
Light bulb.
Canon?
Canon.
The camera?
The camera.
Oh.
Yeah.
Delighting.
I don't know.
I don't love
It's
it.
Canon. Find some products.
It's
that
canon.
Are
You
based
can't argue
on-
with that.
Find some products based on diffraction out there. I'm
Sure.
happy to hear what you come up
We
with.
will. That's fair.
Space news. There's some launches coming up.
Launches! is, and not just like regular launches, more exciting launches
Because
now
they're
there's
sciencey
like, 'cause they're
instead of just
sciencey.
freaking Starlink
Yeah,
satellites.
exactly.
And I've heard
Right.
of some of them.
Yay! So first we have, I think tomorrow, as we're recording tomorrow, so Tuesday, February 25th is when the Sphere X and Punch. When are those launches?
Friday.
Those are Friday. Okay, so Wednesday on February 26th is when the Intuitive Machines 2 mission is going to launch. And so this is launching on a SpaceX vehicle, SpaceX Falcon 9. And Intuitive Machines has had one launch to the lunar surface already. That
Successful. Is that the one
it
that
did
kind of fall over a
successfully
little
get
bit
to the lunar surface, yes, and then it sort of toppled over
onto its face?
onto its side or its face or something, yeah. So they're launching their second mission on a SpaceX rocket this week. And then additionally, there's a mission called Lunar Trailblazer that's an orbital mission that is launching on the same vehicle
Orbiting the moon.
and will be orbiting the moon.
Oh, I didn't know there were two.
Yeah.
On the same vehicle.
Same vehicle. It's a
fun.
ride share.
Okay.
So very exciting.
Nice.
And
You
Carrie
get a
Donaldson
bargain.
Hannah is a
Just like
co-I.
Uber Pool
Exactly. Yep.
to the moon.
Yep.
Great.
Yeah.
Ride share opportunities. So, yeah, Carrie's a co-I on
Lunar Trailblazer.
Lunar Trailblazer. So, and there's going to be a bunch of Trailblazer folks around in the next week, so it'll be fun.
Yeah, and then as you mentioned at the end of the week on Friday, there are these two other missions.
SphereX and Punch.
Right.
SphereX is a spectrophotometer for the history of the universe, Epic of Reionization, and ICE's Explorer.
Which is
It's a
Whoa,
real
that's a
strain
lot of
for how you
stuff.
get SphereX out of that. First
Yeah.
of all, also it's a lot of things.
yeah, it's a very tortured acronym.
It is. So these are launching, I think, from Vandenberg actually, later in the week. And SphereX is going to be because they're both going into polar orbits, which we typically launch out of Vandy.
Okay.
And SphereX is going to create a 3D map of the entire sky, gathering info about galaxies and the history of the universe to study sort of, back in time.
They mentioned 450 million galaxies
Oh my god.
to be observed.
What if you were that 451st millionth galaxy?
450 millionth and one.
There
450
we go.
millionth and one.
That didn't come out
450
right.
million and two.
Yeah.
And 100 million stars in the Milky Way. And I'm glad you mentioned like the acronym
Yeah, it's awful.
because it's really, really bad.
It's a really bad acronym. We do not approve. That does not get the Walkabout stamp of approval.
It definitely does
It
not.
gets the Walkabout womp womp.
It's like spectrophotometer for the history of the universe, ... Universe, that's not in there.
No.
ICES is not in there.
in there.
Right,
Yeah, it
yeah.
just doesn't.
Yeah.
Then the other mission is, and this is also a ride share. Oh, go ahead, Jim.
What is the ICES part?
I don't know.
Oh, I was looking at that and
Yeah,
it's like,
what ices?
I thought, is
Like-
this like simultaneously looking at the polar caps or something? But no, it's about volatiles in the Milky Way.
Oh,
So some
What
of
kind of
it's,
ices?
it's
volatile ones.
It's water or ice or whatever, ammonia, stuff like that.
Volatile ices. Yeah. Okay.
What?
It was a joke.
Yeah.
Okay.
This is also a ride share, and the Punch mission is also on board.
Right.
And Punch is the polarimeter to unify the corona and heliosphere. Much better acronym.
Much better.
And so this is going to be looking at the sun's corona as it goes into the solar wind. So sort of the outer portions of the sun's layers as it transitions into the solar wind. So it's a heliophysics mission.
And it's 4 satellites that are orbiting the Earth over the day-night boundary.
Fun.
So they'll always be
interesting.
seeing the sun, right? Because they're over that
Yeah.
day-night
Pretty
boundary
cool.
on polar
That's
orbits.
Pretty cool
So they're never,
proposal.
from the point of view of the sun, they're never behind the Earth,
Yeah.
right? They're never
Pretty cool.
over the night
They're
side.
like right. There's 4 of them that are right on the boundary.
Yeah.
Interesting.
Yeah.
I wonder why they need 4 in particular
Better
instead of like
information.
2 or something.
Yeah, their solar wind is the part where you need more than one.
Oh,
So
that
you're
more-
observing the corona, but you're also detecting the solar wind.
Okay.
And the
so
solar
it's like a
wind
bigger
is
collection.
affected by the Earth's magnetosphere, so you need as many
Cool.
detectors as possible. That's why I'm waving my arms around.
Yeah.
Solar wind
Nice
dance.
solar
Totally.
wind dances, y'all.
And so the SphereX thing, Jim, is an infrared thing. So it has 102 different filters, and it maps the whole sky every 6 months 102 times.
Oh my god.
Just 102?
102.
They couldn't get 103? Again, with these numbers.
I know. Yeah. but it's 102 filters.
Oh, that's
So-
fun. I wonder how many asteroids are going to pop
So they'll
in.
be looking at the spectra will tell them something about distribution of water in the Milky Way, for example, water molecules.
I like
Yeah.
missions like that because they're very like obviously one of the big points of that is looking at the very early universe and reionization, and the other part is
Yeah.
stuff about the Milky Way and ISIS, of very different kinds of physics and astronomy.
Yeah.
With one instrument.
Yeah.
I like it.
That's awesome.
There's a Dimorphos Didymos 2024 YR4 update.
Those are two different updates.
Yes,
two
but they're
different
kind of connected.
They're sure.
They're both tiny things.
Yeah, the YR4 2024 YR4 update is that it is now a level 0.
Boo!
Yeah, so it was up at a
Boring.
level 3, which means a greater than 1% chance of
It was like a 3% chance almost.
At one
yeah,
point,
yeah. But as a part of level 3, part of that designation is with more observations, it will likely go down to a level 0, and more observations have been done, and now it is at a level 0.
Can it go back up?
It probably won't. No, it probably won't, because the reason why it went up is because the uncertainty with its
Yeah.
with its orbit, the uncertainties were so large, but we've gotten the
more data.
uncertainties smaller
Down.
and smaller, and so
Yeah. Okay.
yeah, but it'll still come
I was under
by
the
Earth
impression
pretty
that we weren't going
closely.
to get that data until it like came around next time. That we weren't going to know.
That's what they
anymore.
were
Yeah,
saying.
that's what I thought, too.
I was kind of looking forward to spending the next
4 years.
several years
Kinda,
in
yeah, me
some
too.
kind of anticipation of
Yeah.
cataclysm.
I mean, maybe when it comes close again, it'll have had some weird perturbation from another planet, and
Yeah.
it will be.
Could be.
Maybe, yeah. I mean, yeah, it is going to come pretty close to Earth still,
Yeah.
4 years
and
or
so
whatever.
it could still be
Well-
an interesting object to keep
Yeah.
looking
We
at
should
and keep
plan
studying.
some recon mission.
If
Yeah.
if it were still potentially an impactor for us, then we might have drawn on what we learned from the DART mission
Yes.
to Didymos Dimorphos.
Good segue.
Yes, yeah. So the DART mission was the first of a mission like on the planetary defense realm, and there was a small satellite around Didymos called Dimorphos that we smashed into. And pretty much right away, we were able to determine that the orbit of Dimorphos around Didymos changed, and that was
That was the goal.
That was the goal. The goal was,
Right.
can we change the orbit? Nailed it. Did
Done.
that. So now a little bit more analyzing of the data has gone on, and it looks
Whatever
like
it is that those
well, all of it's dynamical stuff.
analyzing people do.
You know, oh yeah, I had to take notes on it because I don't fully understand all of it. But yeah, so Dimorphos is now probably prolate, so it's got a different shape, but we weren't entirely sure if it's
Did it change its shape or did it reorient?
it's. I'm not clear. I
Yeah,
don't know.
prolate's like a cigar shape
Yeah, yeah.
We see a lot of things like
instead
that.
of like a
weird.
frisbee shape,
Oh yeah.
Right. Yeah, that would be more
oblate.
oblate. Yeah.
Yeah.
It's likely tumbling in its rotation around
Mm-hmm.
Didymos, which kind of makes sense. We like smacked into it. So.
But also it maybe would have been
Yeah.
already. If
yeah,
it wasn't stable yet.
yeah, that's true. But now it's probably
Definitely tumbling.
definitely
Yeah,
tumbling.
we screwed that thing up.
Yeah, and also there's probably still ejecta in the system as well.
Ooh.
So
In the orbit.
yeah.
Yeah.
So the follow-up mission, the European
There's
Space
a European
Agency,
thing.
yeah, follow-up mission that
Hera.
will, Hera, that'll launch next, not this October, but October of 2026.
Oh, I thought it launched last October.
No.
Oh, okay. The abstract of the
Hera already
paper.
launched.
The abstract of the paper says October
Oh.
2024.
Maybe it
Whoops.
gets there next year.
Oh.
Yeah.
I think it launched already.
Yeah.
Oh,
Yeah,
Okay.
October 2024.
Yep.
oh yeah, it does
You
say
just
that.
went the wrong
Arrival in
direction in time.
2026.
There we
That's
go.
it.
We figured it out.
Yeah, but so they'll have to watch out for some ejecta in the system.
Uh-huh.
Hopefully there isn't too much.
I saw a crazy plot from JWST, speaking of ejecta, of like that they have that's basically like their flat fielding, I think, but it's showing all the little black spots on it of where its head hits, and there's some that are like rings.
Oh, really?
Changes to the mirror structure. Yeah.
Oh, wow.
Yeah.
Oh,
Yeah.
yeah. Well, it's a big
man.
old surface out there
Yeah,
in space.
that's true.
Yeah. Cool.
Yeah.
let me drop the trivia on you guys.
Don't hurt us.
Okay. You
Watch
can
out, Jim.
use diffraction
Oh,
if it
good,
feels
great,
like it's all
great.
coming right
I
on
will.
you. The Sphere X mission, as we've discussed, includes a scientific objective of understanding distribution of water in the Milky Way. So our trivia concerns the distribution of water, or more accurately, the quantity of water here on Earth.
A
You
lot.
may have seen these graphics that
Yes.
show,
So,
like, take all the
like
water and
the
make it a
marbles.
droplet.
Yeah. Yep,
Yeah,
I've seen that.
So how big are those droplets? That's basically your trivia.
Oh.
If you took all of the water of planet Earth, on it, in it, above it, atmosphere, everything, and made a sphere out of it, how big is that sphere? If you took all the fresh water from lakes and rivers only, not like Antarctica or Greenland, but all the lakes and rivers, fresh water, made a sphere out of that, how big is it?
Okay.
And then finally, if you took all the water in the atmosphere at any given time, it's about the same number at any given time, and made a droplet, a ginormous sphere of water out of that,
Yeah,
how
okay.
big is that? Okay.
Okay.
All right. So we'll come back to that.
Good questions.
Great questions. Thanks,
Yeah.
Jim. I'm glad you approve.
Well, Jim,
Yeah.
since you have the floor, can you tell us about, I hesitate to say the name, Quipu?
Quipu.
Excuse
you.
me.
I don't actually know how it's pronounced, but I will say this: I've known that word for decades because it's a
What?
Why?
popular Scrabble word. I mean, not super
Seriously?
Really?
Ah, nerd.
Yeah. I mean, it's named. So this is a structure we're going to be talking about. There's the biggest structure yet discovered in the universe. They named it
Oh, okay.
Quipu after some like Incan counting kind of thing or something like that. So,
An Incan count, like an abacus
Like
or
an
something?
abacus? Yeah.
something like it's or a system of. I don't know what it's worth. This is the problem with Scrabble players is they know all these words and don't know what any of them mean.
They're recording
So-
devices fashioned from knotted cords that were historically used by various cultures in the central Andes of South America, most prominently the Incan Empire.
Okay.
Oh, they're really cool looking.
Yeah. So it's
Yeah,
it's
yeah, pretty cool.
And
kind
it
of
kind of makes sense because of like the structure we see probably.
it's sort of okay. So it's recording things with strings and knots and things.
Oh,
So it's not
Right,
it's not a
And the idea is
deity
neat.
or anything like that. It's a thingy.
Right, it's a thingy.
Yeah.
It's a thingy.
Quipu.
So
Not a
it's
proper noun.
both a
Quipu. I had
proper
to
noun
Quipu.
and general. Yeah,
Quipu.
I had to see the doctor for that last month, but turned out to be okay.
Is that what's? I feel like there's a dog breed merging in there somewhere. What about Quipu?
Yeah, that's, this is another of these things where it's a superlative. So we keep finding kind of bigger and bigger structures in the universe, and this is the new current record holder for largest structure we've seen. And of course, structure is kind of very loosely defined here, but
Right.
structure in the universe. It's a big, long kind of filament. So it's not just one galaxy, obviously, not just one cluster of galaxies, not a super cluster of galaxies, but some
Ordinary
string of-
cluster of galaxies.
yeah, it's a string of collected clusters and superclusters, and it's got knots and stuff in it, just like the Quipu does. And so I guess that's why they named it for that. But it's enormous. It's something like 1.2 billion light years long.
And is it, from your description, it sounds filamentary.
Yes.
Okay.
Very.
Whereas some of the other structures that have been talked about have been more sort of bubbly. Am
Right.
I correct?
So this,
True.
Yeah. Yeah.
So
this
this-
is more.
More one-dimensional.
Yeah. Yeah. Big long filament.
1.2 billion light years.
Oh my God.
So,
That's big.
but still not posing a problem for the grand cosmological principle.
No, in fact, it fits right in with that. Our main model predicts that things like this will exist. It's not. I have trouble calling it a structure because it's not a gravitationally bound thing.
Right?
Oh,
Yeah,
Okay.
I mean,
There's like five. It looks like there are like 5 of these structures. I think we've talked about at least one of them before that have been
yeah. I
observed.
mean, we keep finding more of them. I mean, we've tended to look close by for them, and that's when we found things like that. The thing we're part of, which what do we call that thing?
There's
Oh.
Shapley, Serpens Corona Borealis, Hercules, and Sculptor Pegasus.
there's
So
another.
these are the ones that are the kind of newly found ones. But then there's other ones, like Lana Canea or whatever.
That's
Oh,
right.
yeah,
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 yeah.
These are a little bit further away because we've been mapping galaxy distributions further and further away, and see these they're out a ways. But in any event, it's important to map these things because
Is it?
well, it depends on what you. Yeah,
For galactic wayfinding, Josh,
Sorry.
it is important. Or for intergalactic wayfinding, it is important to map
yeah,
these.
it's not going to cure cancer, but it is going to help us understand the interpret results we get, because like if you have a big structure, then as cosmic microwave backgrounds come through that, those photons get changed.
So, but is this thing basically just like, every now and then in the newspaper they talk about how, the planets are kind of lined up. You can see, Venus, Jupiter, Mars, and Saturn. And then, of course, you can't really see it, but Neptune is also there, sort of like
Right.
kind of in some quadrant or something. Is it? And it doesn't really have anything to do with anything, right? Is it something like that? Like these galaxies are just sort of moving along, doing their own thing, and they happen to be kind of like in a line if you squint at it?
Sort of. I mean,
Oh, man. I was so sure you were going to say, no.
well, it's that sort of. I mean, like I said, they're not gravitationally bound, but it is like galaxies are pushed into certain areas because of the way the universe is evolving, and so it's not like you take a salt shaker and pour it out on the ground and you happen to see a clump or something like that. They're in some sense forced into these things.
So something in the evolution of the history of the universe, like there was a bubble or something, and this is like the edge of it, and things were pushed into this line, or preferentially fell into this line.
Right.
Okay.
So yeah, I don't know. Calling it a structure is a little bit iffy, I think, but it's interesting, and it tells us something about how right we are about how things form, and it helps us interpret results we get. Like, you remember last episode we were talking about the Hubble tension once again, and one of the ways you get out of the Hubble tension is maybe we live in a place that's way more dense or way less dense than the average part of the universe.
We live on a string. We live on a Quipu.
Exactly, and that will change how how the universe is
perceived by us,
expanding in our local area compared to on average. And so we need to know about these big giant structures.
I see.
So this is part of that effort.
Okay. So maybe someday this kind of thing will help us have a better GPS.
Yeah.
Or something.
Or something.
Yeah, you never know. Like
or something that we haven't thought
right.
of.
On our generation ships.
Right.
Yep.
Yeah.
But it's going to be really important for your point-to-point travel to Sagittarius A, for instance.
Right.
Yeah.
Yes. And it's certainly not. It's certainly not a structure like Jim is going to build out there for his timeshare. But one of Addie's backup timeshare possibilities is ocean world, subterranean, and just briefly we learned that there's maybe another ocean world, or there's a little bit stronger evidence for another ocean world.
I think we've been going back and forth about this.
To the list.
Yeah, for Callisto. So we're talking now about Callisto, which is a moon of
Jupiter.
So similar to Europa, which we mentioned earlier, Callisto is thought to potentially have. So like if we've looked at it, for a long time and we thought like maybe it's icy, rocky, or whatever, right? But there is more hypotheses that there might be a salty liquid water ocean inside.
So Callisto is the fourth Galilean satellite out from Jupiter. So you've got Io, volcanoes, very much squeezed and pulled by tides, very active, very hot interior. Then Europa, a little bit further out, so a little bit more icy, still a lot of squeezing, liquid ocean, sending a mission there. We'll see what's going on. Next out's Ganymede, right?
Yep.
Ganymede bigger than those others, and it has a liquid ocean, right? I think we're sure. Then Callisto now is the next one out. So the further out you get, the harder it is to stretch and to generate heat from all that tidal flexing. So Callisto is the toughest one.
And the other challenge is that, like, how do we get data that tells us about what the subsurface is doing? That's often from, like, gravity measurements and flybys of a spacecraft that give you, like, the spacecraft responds to the body, and then that tells you a little bit about the interior of the body. Or, in this case, from magnetometer investigations from the Galileo mission. So like this is also reanalyzing super old data
From
because
the
it's all we
90s.
have.
Yeah.
But it's doing a reanalysis with like all of the data from the flyby, and basically the conclusion is that they think that the Callisto's response to the magnetometer measurements they have, Callisto's response is indicative of a combination of a thick conductive ocean and an ionosphere rather than just an ionosphere in Callisto.
Which
so
was one
Callisto
of the
likely
previous
has some sort of
possibilities.
ionosphere, so it does have, like, it's a high radiation environment, right?
Right.
So it does have some sort of charged particle atmosphere thing,
Tenuous. Yeah.
tenuous, but then it might most likely also has a thick conductive ocean that's changing the magnetometer response on these like 6 flybys.
Right. It deflects the magnetic field of
Right.
Jupiter in a way.
Totally
And
nuts. That's totally nuts to me because, like, yeah, it's so far away from Jupiter, and it doesn't like participate in resonances with the other 3 moons, and therefore
Like how, yeah.
And also the
it
surface
has to be
is
like it would have to be all radioactive heating, right? From
Yeah.
something like that.
it seems
Yeah.
crazy
Yeah.
to me that that would be enough to keep it.
well, it's
molten.
not in that primary orbital resonance of Io, Europa,
Yeah.
and Ganymede, but I don't know that means there are no resonant forcings of it
That's true.
or
Yeah.
other, perturbations that are causing some flexing of the moon from
Yeah.
those other moons.
A lot of
Just maybe not as higher order as the ones for the inner moons.
Yeah, a lot of journals now are doing like we always have an abstract and then a sort of a summary and then the paper and stuff like that. And sometimes now they do key points.
Oh.
And this one has 3 key points, which are important, but like the third one is if an ocean is present, it is likely thick and deep. Like that's like just a really blanket statement for a key point. Like that's not really a big science result, but it is good for like
Yeah, sure.
because it's that we applied a multi-frequency magnetic induction method to Galileo magnetometer observations at Callisto is the first point.
Right.
The third point is if an ocean is present,
It's
it's likely thick and deep.
That's
right.
amazing.
Yeah. Okay. Let's talk about, since you're just talking about water. Mm-hmm. Water there.
Here, there, and everywhere.
There, just as a hint, there's more water, including the ice, on Europa than there is on planet Earth.
Yeah.
Okay. So
Yeah.
if you take all of the water on Earth and make a giant ball out of it, what's the diameter of that ball?
Like
All of the oceans, all the water in the ground, all the water in the air, all the glaciers, all the ice caps, everything.
How big's Europa?
Huh. Not telling you.
don't
What's
get
the
to
size
answer
of
that.
Europa?
I'm not telling you.
10% Earth's diameter. I'm like
Okay.
trying to visualize. I've seen this figure before. Where
Yeah.
The, where
Yeah.
the
Well, you have to give a
water-
number in
300
kilometers.
kilometers.
Jim says 300 kilometers in diameter, or about 200 miles or so. Addie says,
I say
because Audrey's in a
150
catatonic fugue
150
state.
kilometers.
150 kilometers. Audrey,
100.
100. Got it.
interesting. So you think the Earth is 1,000 kilometers in
No.
diameter?
No, I knew you were going to say that. No.
Well, you all underguessed it,
Oh,
actually.
Jim set us up for it.
Yeah, 1385.
Oh,
1,385 kilometers in diameter.
really?
That's bigger than I thought.
Yeah.
Okay.
How about now the fresh water?
What?
Ooh,
Lakes and
100.
rivers. Lakes
Is
and
this
rivers.
just assuming the density of water for
Yes.
this calculation? We're not getting any compression?
No.
Okay.
Yeah. Lakes and rivers, not ice caps.
So what was the answer to the first part?
1,385 kilometer diameter.
1,385.
100.
Freshwater?
100 kilometer
100
diameter.
kilometers.
200.
200 kilometers diameter, Jim.
80 kilometers.
Oh.
Jim gets it. 56.
Wow.
No.
So little
56.
fresh water.
Oh my
And then-
God, that's terrifying.
Yeah, right. So you imagine all the fresh water,
Yep.
put it in a ball. It doesn't even make it up into space, really.
No. Yeah.
Yeah. And then finally, if you take all the water in the atmosphere
Oh.
and condense that into a ball of water, how big is that ball?
Ooh, 50 meters.
Oh. Very small. Jim?
1 kilometer.
1 kilometer.
3 kilometers.
Addie gets this one, but still way off. 29
Oh, wow. There's a
kilometers.
lot of water in the atmosphere.
I was surprised.
Wow.
Yeah. If
Look
all,
at that hydrologic cycle.
If all the water in the atmosphere rained out, it would cover the Earth 1 inch deep.
That's kind of awesome.
Why
Yeah.
it floods here sometimes.
Yeah.
All the water in the atmosphere is raining out.
Well, while it may have felt like I don't know, counting water droplets or counting 450 million
very rainy
galaxies
day
with
here
the
today.
Sphere-X mission. It was just another episode of Walkabout the Galaxy.
Be sure to follow us on Instagram and YouTube. You can contact us at wtg@ucf.edu.
Our theme music was composed by Richard Jerusik. Production assistance is provided by Logan Basinger.
Thanks to our listeners in Portugal and around the world. I'm Josh Caldwell.
I'm Jim Cooney.
I'm Audrey Martin.
And I'm Maddie Dove. We're the Astro Quarks signing off until the next episode of Walkabout the Galaxy.
Yay!
Woohoo! We did it!
It was flawless.
Flawless.
Wow.
No notes.
It's probably because I didn't give Jim an outro line.
I noticed